Welcome to Espresso on Electronics, quick sips of media wisdom. I'm your host Anika Sunda, and joining me today is Fabian Delguste. Fabian is going to talk about the future of predictive debugging in SoC development using machine learning. Welcome to the show, Fabian.
Hey, welcome. Thank you.
Fabian, let's start with the basics. Can you explain us what is predictive debugging and how is it changing the SoC development landscape?
Okay, so basically predictive debugging is like a new way or innovative way to efficiently debug, by leveraging from AI and ML technologies. In terms of SoC, so what we can see is basically that should improve drastically the productivity and also allow, the shift left, debugging faster, and at a higher abstraction level. For instance, instead of debugging at a waveform level, now we can debug transaction level and leverage really from AI and ML.
And Fabian, what, in your opinion, do you think is the role of LLMs here, the large language models? I mean, how do you think LLMs are enhancing the predictive debugging process? And do you really think there are any specific models or techniques that have been proven effective in the past?
Sure. So basically, the LLM actually it's a huge opportunity for us to, as I said, improve debug productivity. The thing is, LLM is based on models, and actually, what looking into all the collaterals that are accessible when you debug, like for instance, waveforms, RTL, test benches, log files, assertions, and so on, we can start building models using this, and you just enhance actually the existing, Llama 3 or whatever models, right? And can improve this drastically by providing user information with embeddings and so on. So these models actually get very much enriched. And now when you query, you can not only query like basic things, but as well as something really pertaining to your design or your design behavior, like waveforms or assertions. So it's a huge opportunity. Another example would be, for instance, to look at waveforms, RTL, and also log files, and then we're able to make sure that the behavior is as expected. If not, the predictive debugging using LLM can also explain why actually you're seeing a bug or different behavior, because you have like all the expectations, predictions using the LLM, and then we can compare it versus what actually is being indeed being simulated. The other thing which is a very, very cool actually is we also, for very, very complex operation, and then we can also generate some Python APIs. For instance, in our in Dago debugger, we have a large set of APIs. And sometimes, if we want to do something very, very complicated, we just dump like a Python code that user can run on its own, just to do some, again, some very complex debugging.
So, Fabian, with every innovation, we all know that it brings a set of challenges, right? So, what are some of the hurdles that you've seen or your team has faced in integrating machine learning into the SoC debug and IP verification space, right? And what are some of the countermeasures or some of the actions that you've taken to overcome the challenges?
Okay, good question. So basically, this is emerging technology. Okay, and we know that, for instance, you can predict, you can build like models and so on, but what we've seen is the quality of results actually can vary greatly based on models, quality of specs, quality of engines. So, for instance, if you have like a very bad coded RTL or very specs that are very ambiguous, then it becomes quite difficult to make use of it. That's the first thing. So this is where we need like sometimes some human interaction. The other problem we're facing is here we're talking about huge databases. For instance, it's very typical to debug like for like a billion of cycles, over a very, very large billion gates design. So it's huge. And clearly creating like models based on such large databases can be very hectic. We're clearly facing some capacity and scalability issue. And how to overcome it? So basically, it's specs and so on. There require some very strong guidelines. That's one thing. And the other thing is to deal with like large databases. So we need all the technologies, very smart technologies, just to extract meaningful information. instead of looking at the full spectrum, I mean, we can reduce it, narrow it down, and make sure, this can be digested by LLM, and then so that we can be like a very efficient models.
Absolutely. And so looking at the future, I mean, looking ahead, what do you think? I mean, what is the future of LLM, right? I mean, in the predictive debugging, in the SoC development space, right? And how do you think that, companies, developers, like general audience should be, preparing themselves to adopt to these advancements?
Okay, so basically, again, it's exciting technology, and we are kicking off different programs. And basically, the first one would be just to embed the what we call debug advisor directly in our debugger, our debugger. And this actually, because I mean, everything is there, right? All databases, information is there. So it's just a question of putting together, all the plumbing so that actually the models can be built and also can be connected to the um, sort of a GPT, in the debugger. So how developers should be prepared? So I think it will come pretty much. I think our idea and goal is just to make this available out of the box without a human intervention. But still, I mean, what would be useful is to make sure everything can be sort of LLM friendly, because as I mentioned, sometimes it's difficult to cope with it, or quality of results depend on of quality of inputs as usual, right? And this is where, I mean, using guidelines, recommendation, also like we can guide it to users how to make use of this technology very efficiently.
Thank you, Fabian, for your insights. I mean, it's a pleasure having you on the show. And thank you, listeners, for tuning in. Keep your ideas connected and your circuits flowing until we meet next on Espresso and Electronics. Stay innovative.